Hello and welcome back. Today we're looking at section 2.3, linear equations. So we'll look at, in this one, first order linear differential equations. So first order, remember, just highest derivative is first derivative. We don't have any second derivative, third derivative, etc. So one version is a sub 1 of x times dy dx plus a naught of x. Y is worth g of x. A more useful version of this for us, if we have a first order linear, is to get the dy dx by itself. So basically dividing everything through by whatever this a1 of x function is. So dy dx plus, we just call it p of x times y equals f of x. So not by itself as in its own side of the equation, but as in its own term. So some things that we want for this, p and f, we want to be continuous on interval I. So there's going to be sort of a general same four-step procedure if we have a first order linear differential equation. Our first part of the strategy is to get to this format. So get to the form where we have y prime plus p of x times y equals f of x. Sometimes they'll start you there, sometimes you need a little work to get there. Then you're going to calculate e to the integral of p of x dx. Once you have that, third step, multiply both sides by your result from 2. And what you'll see is that the left side turns into a derivative that looks like a product rule. You'll get something of the form d dx of e to the integral of p of x dx times y equals e integral p of x dx times f of x. So from there, we integrate. If we want a particular solution, we'll finish up by solving for y. If we want an explicit solution or a particular solution, we would just solve for y. So it looks a little strange at first, but once you run through a couple of these, you'll start to kind of see the strategy behind it. You'll get to see a little better why this method works the way it works. So we'll do 7 dy dx plus 11y is worth 5. So first things first, I'm not in the right format. I want that dy dx to be by itself. 7's in the way. So dy dx plus 11 sevenths of y is worth 5 sevenths. So then I'm going to find here p of x is 11 sevenths. So e to the integral of 11 sevenths dx is e to the 11 sevenths x. So we'll choose c equals 0 at this point, instead of adding a plus c on there. So we'll multiply everything, both sides of the equation, by this factor. So we have e to the 11/7 of x times y prime plus e to the 11/7 x times 11/7 times y is worth 5/7 of e to the 11/7 x. So this left-hand side should look like the product rule to you. If we have e to the 11/7 x times y, and I wanted the derivative, I would have derivative of this, keep that, plus now differentiate this. Well, this is e to the cx, so this is c e to the cx, and keep that factor. So this is basically turning it into saying, okay, well, that looks like it's the result of a product rule. So now we can integrate both sides. Now that we're in this derivative equals this other function. An integral of a derivative, they're basically going to knock each other out. The y is not part of this exponent. Just want to make sure that I wrote big enough for you all to see, but still make clear what's in the exponent and not in the exponent. So left side integral and derivative knock each other out, and we'll have e to the 11/7 x times y is worth, hang on to your 5/7, e to the 11/7 of x, and multiply by 7/11. Now we'll add our plus c. So the 7's knock each other out. And we can also divide both sides now by e to the 11/7. So y is 5/11 e to the 11/7 x over e to the 11/7 x plus c over e to the 11/7 of x. A little bit of simplifying there. Y is 5/11 plus c e to the negative 11/7 of x. So you can write it either at the bottom or with negative exponent. One other new idea that they introduced in this section is the idea of a transient term. The idea behind a transient term is if the limit as x goes to infinity of whatever term equals 0, then the term is transient. This being at the bottom of the fraction, basically, if x is getting bigger and bigger, e to the negative 11/7 x at the bottom, positive 11/7 x is going to get bigger and bigger. So our c e to the negative 11/7 of x is transient. In other words, that will begin shrinking as x gets very large. Okay, so our next problem, we're going to have xy prime plus the quantity 1 plus xy, so e to the opposite of x, sine of 2x. So we don't have the y prime by itself just yet, so we'll divide everything through by x. So if y prime plus 1 plus x over x times y equals 1 over x e to the opposite of x sine of 2x. So now I'm looking for e to the integral of, let me go ahead and split that fraction, 1 over x plus 1 times dx. So that's e to the natural log of x plus x. It's e to the natural log of x, e to the x. So here, if you're adding the exponents, it means you are multiplying with the same base, and e to the natural log of x turns into x. So we have x e to the x. So we'll multiply each term by x e to the x. We have x e to the x y prime plus x e to the x. I'll go ahead and split these. 1 over x plus 1 times y equals x e to the x times 1 over x e to the negative x sine of 2x. All right, so a little bit of simplifying is in order before we get too far ahead of ourselves. So x e to the x times y prime. And let's go ahead and distribute these guys. So the x's will drop, so we have e to the x plus x e to the x times y equals, the x's drop, the e to the x's drop, and we have sine of 2x. So we did our little cleanup, which brings us to writing it in derivative form. So the left side is basically the derivative of x e to the xy. So notice if we differentiated the y, we get our y prime, and we would just keep x e to the x. If we differentiate the x e to the x, we would need our product rule, and we would keep our y. So sine of 2x on the right-hand side. So then we integrate. So left-hand side, we have x e to the x times y. Right-hand side, we know we have a cosine of 2x involved. A derivative of cosine would be negative sine, and we would also have a 2 there, so I need a negative 1/2. And we'll add our plus c, of course. And then we'll just divide by x and e to the x. So y is negative cosine of 2x over 2x e to the x plus c over x e to the x. Now on this one, both terms are transient. Cosine is stuck between -1 and 1. E to the x grows without bounds, so that guy's going to 0. Constant over, this guy's going to infinity in the denominator. Also 0, so both minus cosine of 2x over 2x e to the x and c over x e to the x are transient. One other note on this problem, we do have a limit on our interval I. Notice at one stage of the game we had a natural log of x involved, so here I is on 0, infinity, exclusive on the 0. So next we look at one where we are finding a particular solution. So the y prime is 1 minus y times cosine of x. And we're also going to be told that y of pi is 2. So stage 1, we want to get to the right format. We're definitely not there yet. So y prime is cosine x minus cosine x times y. So y prime plus cosine x y is cosine x. Now we're in the right format of y prime plus p of xy equals f of x. Now we're ready for stage 2, where we find the integral. So integral of e to the, in this case, cosine x dx. So we have e to the sine x. My apologies. My notation looked a little weird there. E to the integral of cosine x times dx would be e to the sine x. Again, we choose c to be a 0 plus 0. So we multiply everything by e to the sine x. So we have e to the sine x times y prime plus e to the sine x times cosine x times y equals e to the sine x cosine x. Not much cleanup work to do there, so this is then our derivative. We'll take the integral in just a moment. So this is the derivative of e to the sine x times y on the left, and on the right we have just e to the sine x times cosine of x. So derivative of e to the sine x is e to the sine x times derivative of sine x, which is cosine x, and we would keep the y. Then we would keep that, differentiate y, which would be y prime. So now, jumped the gun a minute ago, now we'll integrate both sides. So left-hand side is e to the sine x times y. Right-hand side, we recognize this as being e to the sine x. And we'll add our arbitrary constant plus c. We'll get the y by itself, so we'll divide by e to the sine x. So y is e to the sine x over e to the sine x plus c over e to the sine x. So y is 1 plus c e to the minus sine x. So far so good on that. Then we finish it off with plugging in the fact that y of pi is 2. We can actually find the c value. Against my better judgment, I'm going to try and squeeze that in up here. So 2 equals 1 plus c e to the minus sine pi. Well, sine of pi is 0. Opposite of 0 is still 0. E to the 0 is 1. So we have 2 equals 1 plus c times 1. So 1 equals c. So then y equals 1 plus e to the minus sine x. So that's our particular solution. Whereas the step before we had an explicit solution. And really, once we got rid of the integrals, this was at least the start of an implicit solution. A little bit of vocab that's going to come back a little bit later. If we have a1 of x, y prime plus a0 of x times y equals 0, this is called a homogeneous linear differential equation. if we have similar setup, a1 of x, y prime, plus a naught of x, y, and we're equal to g of x, and g of x is not the zero function. Not super surprising, the name, non-homogeneous. Linear differential equation, and alternating on and off kind of throughout my own mathematical education, I've had professors pronounce it as homogeneous and homogeneous. So you'll hear sort of two common pronunciations on that. So in section 2.3, I would recommend 1 through 35 on the odds. If you'd like, you can also read up on the error functions and complementary error functions, but I won't do any kind of extensive testing on those or anything like that. And of course, if you have any questions, get in touch with me. Otherwise, I'll see you next time. Thank you.